Okay, so welcome back. So now what we're going to do is I'm going to show you how to find an easy way to find the least common divisor, or in other words, to find the least common multiple of a set of numbers, two or more. So remember, oops, the least common multiple of a group of numbers, two or more, is the smallest number that is a multiple of each of all the numbers. So we want the smallest number that is a multiple of 45 and a multiple of 12. Okay? Now, for numbers like this, now the least common multiple is controlled by the larger number. Okay? So obviously 12 is not a multiple of 45, right? Even if I said, even if I took the next multiple of 24, you know, it still wouldn't work. So the larger number, the largest number, the larger of the two or the largest of the three or more numbers is going to control what the least common multiple is. So sometimes you could be able to do it that way and just find a multiple of the largest number that you can see that the other numbers are also multiples. That number is also a multiple of the other numbers, is what I'm trying to say. But there is an algorithm, a method of finding the least common multiple every single time. And it has to do with the prime factorization of each number. So, for 12 and 45, if I wanted to find the least common multiple, then the first thing I'm going to do is I'm going to write out all the prime factors, or the prime factorization of 12. So that's going to be 2, right? 2 times 2 times 3. Right? So again, you could use the factor tree like I've showed before to get that. So here's the prime factors of 12. 2 times 2 times 3. Okay. Now what about 45? Let's do 45. So the prime factorization of 45, obviously it's not going to be 2, but it's going to be 3, right? Times 3 times 5. Okay. Now, once I have the prime factorization of each number, here's what you do. The least common multiple equals, so here's what you're going to do. You're going to take all of the primes that show up in either factorization. So in this case, 2 shows up, 3 shows up, and 5 shows up somewhere. So you're going to take all the primes that show up in one or the other or both. Now, once you see the primes, then you want to take the number of the factors that is the greatest. For example, 2 shows up twice here, doesn't show up anywhere here, so I'm going to take the 2 with the largest. So this is going to be 2 times 2. Now, for the 3's, I'm going to take the number of 3's that show up the most. So 3 shows up here once, but shows up twice here. So I'm going to take the 2 that show up twice. And then I'm going to take the 5 because the 5 doesn't show up anywhere here, but it shows up here, so I'm going to take the 5. Now, why does this work? It works because you know that any multiple is going to have all 3 of these factors in there. And any multiple of 12 is going to have all of these factors in there. Well, so you're going to have to take everything, but this 3 is already in here, so I'm only missing 1 3. Okay, so that's why I take 3. So these two, right, give me the 12, and then these 3 give me the 45. So both of them are represented, if you will. So now I'm going to multiply, and what do you get? You get 4 times 9, or 45 times 4, right, which is 180. And so that's the least common multiple of 12 and 45. Okay, now, what about the next one? Now here, could I have another one? No. Okay, so here's another one. Now we have 3 numbers. So I'm going to do the same thing. Now, if you look at the 15, you could take multiples of 15 and see what multiples of 15 are also multiples of 10 and 4. So if I go to 30, well, that's a multiple of 10, but it's not a multiple of 4. So if I go to 45, well, that doesn't work. If I go to 60, well, 60 is a multiple of 10, and it's also a multiple of 4. So I got it that way. But let's prove what I get. So 4, okay, so the prime factorization of 4 is just 2 times 2. Prime factorization of 10 is what? 2 times 5. And the prime factorization of 15 is 3 times 5. So now the least common multiple, or LCM, is going to equal what? Well, I'm going to take the 2's. I'm going to take the most number of 2's, which is going to be in here. So I'm going to take 2 of those. Okay, and then I'm going to take 3. So the one with the largest number of 3's, which is going to be this one. So there's just 1. And I'm going to take the one with the most 5's, which is either this one or this one. They're the same, so I'm just going to take 1 5. And lo and behold, if I multiply these out, I get 15 times 4, which is 60. So the least common multiple is 60. So now, if I want to do these next two, I'm going to want to find the least common multiple. So again, instead of doing the rule of 4, because here's the thing. You can do the rule of 4. The rule of 4 will work for any addition of fractions that don't have common denominators. Okay? So you can add any unlike fractions using the rule of 4. But the rule of 4 does not guarantee that you're going to get the least common divisor. Okay? So that's why the LCM is important. Okay? Because if you use the rule of 4, you're going to most likely get a fraction that you're going to have to reduce. And it might not be easy to reduce. Okay? Okay, so let's do this one. Now, if I multiply these two together, I'm going to get 96, right? So 96 may not be the best, the smallest multiple. So let's use the least common multiple. Okay, so 8 equals 2 times 2 times 2, and 12 is 3 times 4. So, in this case here, it actually is going to turn out to be, oh, that's 3 times 4. Not thinking. It's 2 times 2 times 3. There we go. So now, if I take the least common multiple, so the least common multiple then is equal to 2 times 2 times 3. Hold on a second. No, 2 times 2 times 2 times 3. There are three 2's. Okay, so I take the largest, the one with the most 2's, right? So that's going to be these 3. And then the one with the most 3's, which is this one. So then I multiply those together, and guess what? You're going to get 24. So the least common divisor turns out to be 24. Much better than 96. Okay? So now I just have to set this equal. So I want 24 on the bottom. So now, what do I have to multiply the top and the bottom here to get 24? 3. What do I have to multiply the top and the bottom by to get 24 in the bottom? 2. And so now my final answer, 13/24. And that's it. Okay, so let's do this one. I got 6 and 8. Again, you could do the 8 and just say, okay, what multiple of 8 is also a multiple of 6? Because again, the larger number controls the least common multiple. So you can go 8, 16, 24, and so 6 is a multiple, 24 is a multiple of 6. So we can get it that way. So in this case, it turns out to be 24. But again, let's double check. So we get 6, and this becomes 2 times 3. And 8 is 2 times 2 times 2. And so the least common multiple of 6 and 8 is going to be 2 times 2 times 2 times 3, which is 24. And so now, what do we get? We get what? 6 times what equals 24? 4. So we get 4 over 24. And then what times 8 gives us 24? Which that's 3. So 3 multiply both the top and the bottom by 3. And we get 15/24. And so our final answer is 19/24. Okay. If we would have used the rule of 4, we would have gotten 38 over 48. And we would have had to reduce and simplify. Okay, that's it. Have a great day.